Hello students and welcome to another video lecture on logic design. In this video we will continue to learn about complement arithmetic. As you know from a previous video, every number system with base or radix R has two types of complements, the radix complement and the diminished complement. In the decimal number system, the diminished radix complement is 9's complement and radix complement is 10's complement. In the octal number system, the diminished radix complement is 7's complement and radix complement is 8. Similarly, in the hexadecimal number system, the diminished radix complement is 15's complement and radix complement is 16's complement. You are expected to know arithmetic in all these complement forms. The good news is that there is a major similarity between them which you can exploit so that this whole process becomes easy. Let us look at the complement arithmetic in decimal number system. The diminished radix complement is 9's complement. Recollect from a previous video that to find the 9's complement of a decimal number, you need to subtract each decimal digit from 9. To find the 10's complement, simply add 1 to the LSD of the 9's complement to get the answer. Obviously, there is a method to do 10's complement arithmetic and it looks like this. You will understand each of these steps with the working of an example. Subtract 745.81 minus 436.62. Notice that both these numbers are in decimal. In subtraction, the first number is called as the minuend and the second number is the subtrahend. Let us also bring up the algorithm that we saw in the previous slide. The first step tells us to add the 9's complement of the subtrahend to the minuend. The subtrahend is 436.62. Find its 9's complement by subtracting each of these digits from 9. We get the answer as 563.37. The step also tells us to add this to the minuend, which is 745.81. So adding these both up, it's a pretty simple standard addition in decimal. The sum that we get is 1309.18, where the MSD 1 is a carry out from addition. I have highlighted this in grey. Now this carry that you get is a special carry which is called as the end around carry. The algorithm tells us that if there is a carry, the answer is positive, which is pretty obvious since the first number is bigger than the second number. The step also tells us to bring the carry around and add it to the LSD. So let us do that. Bring the carry around and add it to the LSD. We get the answer as 309.19, which is the answer that we are looking for. There is another step in this algorithm, but we will tackle this in another example. Now let's rearrange the numbers as 436.62 minus 745.81. Obviously, the result of subtracting these two numbers should give you the same answer as the previous slide, except that there will be a negative sign. In subtraction, the first number is called as the minuend and the second number is the subtrahend. Let us also bring up the algorithm we saw in the previous slide. The first step tells us to add the 9's complement of the subtrahend to the minuend. The subtrahend in this example is 745.81. Find its 9's complement by subtracting each digit from 9. We get it as 254.18. This algorithm also tells us to add this to the minuend, which is 436.62. So adding this up, and it is pretty standard addition, okay, we get the answer as 690.80. Notice that there is no carry. So the algorithm tells us that if there is no carry, the answer is negative and in 9's complement form. You need to find the 9's complement of this answer to get the correct answer in decimal. So let's do that. Find the 9's complement of the answer to get 309.19, which is the answer that we are looking for. Don't forget that the answer is negative, so put the minus sign. That's all for now. Follow up on videos which will be put up shortly on 10's complement arithmetic. Connect to the classroom for further videos and learning material.